All right, everyone. I just connected my AirPods. Can you all hear me clearly?
Loud and clear for me.
Awesome. Okay, let's start our cameras. Okay, great. Good to see you, John. Been a couple days since Dubai.
It's been some time since our lovely flood adventures in Dubai. Yes.
That was a memory to never forget. That was an interesting experience. So let's jump in here. Our team has been working together. You and I, John, have been working together almost 7 years, right? From back in the days with Uni Chain. I used to live in San Francisco. You were in Taiwan. We met in San Francisco Blockchain Week 2018, January. And we were like, hey, there might be something to this notion of tribes and clans. Let's be honest. We didn't really know what we're talking about.
We were
We
young.
knew this, we were young. Yeah. We were young. We knew, however, that this technology mattered. And it was only until we were able to work with folks like Dr. Kate and others that we realized this had potential. I have a background with online gaming. Back in the day, I used to be concerned about on-chain randomness, or excuse me, randomness in general, like online randomness. I had a background with online poker, and me and my co-founder back then, this is like, we're talking about like 15 years ago, I used to question, are these online casinos telling the truth? I feel like these metrics are not correct, but there's no way to prove it, right? And, you know, fast forward to San Francisco days, I moved there in 2013. 4 or 5 years later, I got to introduce you, John. And you were also already in the blockchain industry, working in blockchain. I would love to hear for us to share collectively to the group. What was it about blockchain technology that brought you into the field? And what was it about our interaction that said we should work together? We're talking about like late 2016, 2017. We'll talk about where we're at today. But yeah, John, would love to hear about your story.
And I just thought of this and it's actually rings really true. Blockchain is a source of truth and it's something you trust. It's really comes down to trust. And when I met you, Josh, the first thing I felt, because we had mutual friends that knew each other, I thought this is a person I could trust, potentially work with in an industry that not you can, even though blockchain is about trust, this industry was so new and it's still so nascent and growing that trust is sometimes hard to find. And I remember thinking that Josh and I had mutual friends. I could try to trust this person. And you had really impressed me as a great software architect. It's a skill and quality that I necessarily didn't have at the time. But I thought I could probably do really well and we could really work together based off trust. And so blockchain is a trust system. And meeting you, Josh, I felt that you could be someone that I could work with. And so I was living in Taiwan at the time. I graduated from UC Berkeley. Actually, Berkeley was one of the first university clubs that embraced Bitcoin and then blockchain. And I have a whole story around that. But I was happy to go to that university, get introduced to Bitcoin a little bit back then. And then in Taipei, starting Taiwan Entrepreneur Club and getting introduced to Ethereum in 2016. It really interests me. And I met Josh 2017 in San Francisco, and we went from there. Josh moved to Taipei. We started to work together. And if you can believe it, 2018 was a horrible bear market. So we started all energetic and like blockchain's going to change the future. It's going to change the world. It's a system of trust. And then nobody wanted to invest in us. And no one wanted to invest in any decentralized protocol or L1 because the whole token model was messed up. People were thinking, is token an investment? This is like after the ICO boom and crash. And so a lot of the traditional investors, including retail, were a little bit wary of how do token economics work? How can we invest in like decentralized protocols? And that's the situation we were in at that time. And I think the core of sticking with understanding that blockchain would change the world in many ways, that it's a trust system. As long as we kept building, we could build something special. So yeah, that kind of goes into what we wanted to talk about today is that since our early mission and our early vision was to create an L1 all the way back in at the start, 6 years ago, 6.5 years ago, Josh, you pitched me a consensus algorithm with tribes and clan model. And you said you wanted to go big and create an L1 that can outscale Ethereum at the time. And that vision was so big. And I have to admit, I was attracted to that, but I'm also a little bit afraid because these big visions of competing at that level is super scary, to be honest. And I feel so lucky and valuable. And I feel like I'm so proud that we've made it this far.
And I want to say absolutely thank you, John. Hey, we've been on this journey for so long, and we thought it would take a little bit faster to get here. But actually, the truth of the matter is, we didn't know what we were talking about. We did look into the deep with the right intentions. That was what kept us going. But it wasn't until we brought on folks like Dr. Kate, Dr. Rob, Dr. Yang and beyond. We have such a wonderful team. In fact, honestly, most of our ideas were wrong. However, the concept and general framework had some merit to it. So the truth of the matter is, we jumped into this with the right intentions and we brought it through a bear market with the right intentions. And if you were to see John and myself at the Impact Hub in Taiwan with no support, a small team, like 6 or 7 of us, we had stacks of white papers. We studied protocols. We were diligent. We did the work. That led us to Dr. Kate's work in decentralized distributed key generation in particular. And there's a really wonderful story about how we got introduced to Dr. Kate over the years. He was so gracious to actually respond to a cold email that we said to him, hey, what if we did it this way? And by the way, to be honest, John and I didn't really know what we were talking about. 7 years later, you start to learn your chops. You start to study deeply. And you start to get good if and only if you surround yourself with experts. And that's the wonderful privilege that we have done. And we will definitely be jumping into this with Dr. Kate. Dr. Kate is the chief research officer and lead of our entire system, not only architecture, research, and beyond. He really grounds us in both what could happen and why it should be okay to consider ideas beyond the box, right? So we're definitely jumping into this. We're very excited to share more with Dr. Kate. Dr. Kate is the inventor, one of the co-inventors, the lead inventor of KZG commit. So you may have heard of data availability sampling. Many of those protocols are based off of KZG commitments. The K is Dr. Kate. Man, it's such an honor and privilege over the several years to work with Dr. Kate first as a email open source like conversation to bring him in to be an advisor and then also ultimately to somehow, luckily, convince him to work with us, which is great to bring us forward. And we will move into our conversation with Dr. Kate and our super insights momentarily. In the meantime, what we want to do is, John, if you can share a little bit more about what is it about Supra is different than other chains, like integrated protocols or monolithic protocols. These are nomenclatures that we need to work through. But yeah, please jump in.
Sure. And so like I was saying, our original vision, which might not be known to everybody here or listening, most people think of us as super oracles, and now we're supra.com. And so most people, when they think of Supra, they might think of us as just an oracle. But I want to let you know, and we want to let you know that our vision from day one is actually building an L1, a vertically integrated L1 with native Oracle, native bridge, native automation, as well as multi VM support, multi virtual machine. So, for example, EVM or Ethereum applications can deploy onto Supra. Solana virtual machines can deploy on Supra, or Move out if they would be able to deploy on Supra as well. And so this vertically integrated stack of native Oracle, native bridging, native automation, we think that this type of architecture, along with our high performant moonshot consensus, which we'll go into later, which we have over 500,000 TPS, which is like a core engine of our protocol is necessary in order to build what we call super dapps or super applications in Web3. And so this vertical integration is different from what a lot of companies are touting as like module, modular blockchains, modular build. And I think Josh will make it clear and Dr. Kate will make it clear later that Supra is actually built in a very modular way. So that we want to be clear, we're not against modularity, but like the iPhone, we care about vertically integrating these services into one L1 security paradigm. Whereas modular networks or modular dapps or applications have to deal with a lot of L1 security risks. For example, if you introduce an Oracle, external Oracle, your application is no longer as strong as the L1 that it lives on. It's now you introduce a third agent, a third party that now you're as weak as that Oracle. Or if you introduce this bridge that only has two-party consensus or two agents like Oracle and Bridge, you're now reducing your security of your application to that bridge. So no longer have these L1 security assumptions. So you have this latency as well as latency, right? Network application. So we know at Supra, when you vertically integrate these services, that you can have more efficient, faster, and better applications with the L1 security principles and very low latency because it's one network. So we built this from the beginning. And that's why it's been a 3-year journey. But we're here today and we're alive and we're thriving and it's exciting.
Yeah, exactly. What we're doing is beyond just data feeds. We're actually trying to bring forth what we think is the ultimate blockchain design. We look forward to the future and what does technology generally trend towards? It trends towards vertical integration. So once again, to echo what John has shared, the status quo today is this modular architecture where you have a different network, literally a different set of nodes somewhere else for one service, different set of nodes for Oracle, different set of nodes for data availability, different set of nodes for execution, different set of nodes across your communication, different set of nodes for automation. In that situation, what you end up with is, for lack of a better term, and this may be a little bit controversial, you end up with a Frankenstein Dapp, where the weakest link, your security of your application is this weakest link of that network which you communicate or engage. Moreover, sometimes your application literally cannot function without having this network execute first, wait for finality, get a response, have another network execute next, get a response and finality, compute the cryptography X, Y, and Z. Remember, the speed of light around the world is about 133 milliseconds. So if I was going to go from one system to another and let them communicate among themselves, let them respond back to us, then now we have to respond to another system, X, Y, and Z. You search it out latency. So it's not only about security issues and you're only as secure as the weakest link, but you're also adding latency to communicate with all these modular components. Now, let's think about the future of technology in general. Like, I think the best instance of this is iPhone. So the iPhone has exactly, you have a large screen, vertical integration of database, compute, Wi-Fi, telecommunication, GPS, one device, database as well, right? So one device, right? So you don't have one like machine where you have an external plug and play for Wi-Fi connection, another plug-in for your database, another plug-in for execution or beyond, right? Which is very cumbersome. But all in one, which we've seen works in the real world, Web2 world for iPhone. We believe strongly that this just makes so much sense that this should happen in blockchains. Blockchains are not computers unless they can communicate with each other, unless they can communicate with the outside world, and unless they have the ability to execute if different conditions are met. Now, what we're going to jump in here is going through our community update. We're going to talk about some of these updates. And the next thing here is we're going to jump into how Supra does this differently than any other ecosystem. and why our insights are so different and important compared to what is done in the past. So jumping in here, okay, let's go to the next slide. I'm actually not able to click this. My, oh, here you go. I got it. Okay, so we have a huge community. We have over 100,000, excuse me, a million point two verified. Let me say it again. We have 1.2 million folks on our contact list, of which about 512,000 have actually verified KYC through Supra. Now, this should set a world record for an ultimate layer one with that many token holders, right? And we actually did the work to actually KYC our folks. Now, do we really care about the specifics about KYC? The main thing we care about is civil prevention. Earlier, when we launched our program, we actually had 50,000 people sign up in about 3 weeks, which was like, wow, this is amazing. And we looked at the data and it looked like there were some folks that actually were able to create 3,000 accounts with the same identity. So we worked with a Web2 reputable company called Pompedo to do something called facial recognition. Um, Basically, this notion of facial recognition and KYC for passports, identity, to make sure that folks are not replicated so that we can have a fair distribution. In the end, what matters in a decentralized community, it turns out that what really matters is actually having the token distributed broad and far. So we have worked towards this. We actually invested in this. This is not something that was an easy decision. Nonetheless, other than WorldCoin, right? WorldCoin does have, I think, over a million folks through their iris scan KYC. Nonetheless, that's a layer two. And in our understanding and our research, Supra had 512,000 KYC individual token holders. This will set a world record. I think this will get into the Guinness Book of World Records for a launch of a layer one. And why is that important? It's important because the distribution or token creates decentralization. And moreover, it creates what we call implied network effects, the implied odds of creating network effects. So we're going to go through our community update real quick. Then we're going to go through our technology. And you're going to see in the next 6 weeks that we have a very specific rollout plan. There's so much we do at Supra. This is not just, oh, hey, we're going to tweak this layer two, X, Y, and Z with this little bells and whistles. No, this is first principle thinking to reimagine the next generation of this technology. Okay. So yes, it does take some time. And some of you folks have asked us, when are we going to token generate? So when are we going to issue our token? I can tell you the following. We are talking to the biggest market makers in the world. We're talking to the biggest exchanges in the world. And the bottom line is we only have one shot to do this right? And this is by and large a life's work. So we cannot rush this. What's more important is launching correctly, making sure that our folks that have participated collectively, 500,000 people, verified users are going to be token holders. This is a world record. We have to make sure that we do this the correct way. And yes, it takes a little bit of time. Nonetheless, it's very close. Now, you're going to be asked over time to verify your account, download our wallet, claim your tokens. These are all coming in the next several weeks or months. I just want to say we have been working on Supra specifically for almost 40 months. So we're very close. We're talking about only a couple more months to get there. And guess what? It looks like the ecosystem will be the market at large is very receptive to the next generation blockchains, right? So this moves into the next conversation. So we start with oracles. And as John mentioned, that was never the first thing we're going to do. In fact, we always knew that we wanted to have a high throughput, low latency consensus algorithm with native oracles. We actually had that insight in 2017, believe it or not. Do we exactly know what we're talking about? The answer is no. But guess what? 6 or 7 years later, working very hard with computer scientists that are literally gigabrains, the top of the top, step by step iteration, you get there. And this is where we're landing today. Now, if we were to launch this 4 years ago, would we be as good as we are today? The answer is absolutely not. Where we're at today, we're introducing a new class of applications. We call them super dapps. Okay. So super dapps that are only possible on Supra. Why is that only possible on Supra? It's because Supra is providing a high throughput, low latency consensus algorithm to do our verified moonshot consensus protocol, formally verified, meaning this is mathematically proven to not work. Moreover, we have native Oracle pricing, right? It turns out that at least a third of the biggest applications in blockchain need Oracle data. The other things they also need in a multi-chain world and environment is cross-chain communication. They also need automation. Automation is a decentralized if, this, then that. And the last thing they also need, which we are pioneers on, are on-chain distributed verifiable random function. If anyone knows about computer science, they know that blockchains are deterministic systems, right? Meaning that they are very orderly. So bringing on-chain randomness is a very interesting esoteric topic. And our team has such wonderful ideas around this. In fact, we have 3 or 4 protocols that we're developing already beyond what we've brought to the table. In our DVRF, one of our designs that we recently gotten into CSS, which is a top dev venue. And I want you all to know that Supra, yes, some of our backers, investors, and say, hey, Josh and John and team, why don't you promote yourself way more aggressively? It's because Supra is dedicated to authenticity and integrity. We don't do this until we have peer review and data. Now, do we believe we have the goods? The answer is yes. 100%, we do believe we have the goods. In fact, we could not retain the talent we have. And you're going to see momentarily a presentation from Dr. Kate. Dr. Kate is not only a genius in the space, it is adopted, his technologies and ideas are adopted by Ethereum and EigenDA and beyond. So EigenDA literally does not work without Dr. Kake's KZG commitment. And Ethereum's layer 2 roadmap does not work without his intention. So does Supra really take science serious? The answer is yes. And that's good for all of us because guess what? If you're going to power the world's value exchange, you need to make sure this thing works fundamentally. So yes, Supra is not a hype chain. We're a fundamental chain. We care about fundamentals and what we can build and what we're introducing to the world is something that you cannot build elsewhere. We started this conversation about Frankenstein dapps, where a layer 1, you have an external system for Oracle, external system for cross-chain communication, external system for on-chain randomness, external network for automation, right? Along the way, your application has now inherited the weakest link of the security of which service you provide. Moreover, you have to manage multiple gas tokens. Different systems have different gas prices and they spike and they're very difficult to manage. Moreover, you introduce latency, right? So what is a super dapp? Imagine if your application could deploy on Supra and imagine we can handle EVM, Solana VM, virtual machine, Cosmos, and MoveVM, one system. So multi virtual machine support. We can handle multiple smart contracts. And imagine block by block, you have Oracle data, pricing data block by block deterministically prioritized. You always land that information. Imagine you have the ability to communicate to other chains in layer 1s and layer 2s. And also you have the automation service, the decentralized if this, then that service. There's really amazing things that can be done with this. I want to continue with this presentation to share more. So we talked about super dapps. So a super dapp, and what does that mean? It's any application across any of the virtual machines that we support that can leverage our local price feeds, automation, on-chain randomness, cross-chain communication. If you leverage any of 2 of those services, by the way, these are services that don't exist blatantly in their ones, right? It's only an afterthought that protocols are thinking, oh, wow, actually Ethereum nodes can be running active validator services, AVSs. through eigenlayer to do more things, right? The question is really what it comes down to from a first principles basis is, okay, can my node, do I have enough bandwidth and compute to do more than just consensus? The answer is yes, but there is a limit, and we'll talk about that limit. So imagine an application that deploys in Super that has access to our native price feeds, block by block. So we have Oracle data block by block, deterministically finalized. You also have access to our automation service to decentralize if this and that. What this can enable is a on-chain next generation perpetual DEX decentralized exchange in which these liquidations are actually executed deterministically, transparently, and in such a manner where the application itself can be allocated half the revenue. Imagine if 50% of the revenue from liquidation reward went to the application. Imagine if 25% was equally distributed to the node operators. Another 25% was to Supra decentralized treasury, which everyone contributes towards. This mitigates this perverse incentive of having these auctions and this notion of, okay, let's auction off the block space, the next space, and have Oracle extractable value. Imagine the future in which this is deterministically automatically executed. And moreover, the application itself has a new revenue source. Right now, these applications or perpetual DEXs don't necessarily collect this liquidation fee, but generally is 1% of the liquidation, right? So imagine that you have access to Oracle price feed data block by block. You have deterministic execution through our automation network. You have smart contracts across multiple virtual machines. This is going to create a more fair environment. It's also going to be more not only fair for the end consumer, but also for the application itself. We have multiple different examples of what are super dapps. And what we'll be sharing more to the community and by and large is a super dapp competition. It's going to be about 3 or 4 months, but ultimately we have really wonderful incentives. Super already has 512,000 KYC verified users, individual token holders. We will put our audience, as I mentioned earlier, about 1.2, 1.3 million email contacts. We'll put our audience in front of your application. You apply in our competition. You'll have multiple venture capitalists and VCs and investors, as well as computer scientists judging the submissions. We'll select the top 20 to 50. We'll put you in front of our audience. We'll help you bootstrap an audience. We'll help you get exposure. And this is, remember, for application developers, we're going to bring you something that you literally cannot build anywhere else. So moving forward here, I know we're a little bit ahead of time. I'm just going to go through this community update. You have access to this. You can read it in detail. By and large, though, the other major thing that I want to share is we have worked and commissioned Delphi Digital. They're an OG research firm in the space. They've worked with many institutions, and they had to actually study like 7 different protocols to understand what Secret ultimately is doing to put it all together. Supra's ultimate vision is vertical integration, meaning a single network in which each individual node operator can operate more than one service. It doesn't have to be only consensus. It can be doing Oracle services, cross-chain communication services, or on-chain randomness services and beyond. If you don't have access to our Delphi Digital report, this community update, reach out to us. We'll send it to you. This has been growing fast. And while the Delphi Digital, this is a third party. They have their own opinion about us. We don't necessarily agree with everything they say, but to be honest, we think they did a great job as a third party analysis. So please do read this. It talks about each of our individual protocols and how we vertically integrate this ultimately. So as I mentioned, this is very interesting, and I do believe we will actually enter the Guinness Book of World Records for a layer 1 launch with this amount of non-civil verified token holders. Many of you on this call right now are token holders through our Project Blastoff. We're at, I think, mission 51. So we had week by week missions over almost close to a year. You can imagine another 4 to 6 months to prepare for the system. This worked exceptionally where we also KYC to everyone, not because we care about your specific identity, we care about gaming the system. We want to make sure we actually have a fair distribution of our token. Now, we have over 190 countries represented in our program. This is a, a project in which we put together our best ideas, viral marketing strategies. Uh, it's an education process. We also randomize our question and answers. So folks actually have to pay attention. Moreover, we did use like AI techniques for voiceover, and then Supra will always be on the forefront of the latest technology. Nonetheless, I want to make this clear that Supra, as far as I know, is going to set a world record for amount of token holders at large. And all those token holders will have the option to actually delegate the majority of their token that otherwise would be vested to node operators. And we think we can also set a world record with your help of the most delegated, the most amount of individuals that have delegated the token to node operators. And we work with some of the best in the world. Moving forward here, you'll learn a lot more about how to redeem your super token, how to actually stake it to node operators and earn block rewards and such. There's so much more to share. You got to understand, Supra literally has some of the biggest, best brains in the industry. Dr. Kwate, for example, is famous for distributed key generation technologies and techniques. There's so much more coming out, but I want to share that Supra is rolling out a Star Key wallet. Star Key wallet is a multi-chain blockchain wallet that's non-custodial, meaning you manage your own keys, and what we focus on is basically key recovery. So you have this standard key phrase and you have random 13 words you have to remember, which you have no association or mental connection with. We have developed this a multi-key splitting strategy where you can actually have key recovery through multiple sources in which makes sense for you. You have social recovery with like Google Drive and other sources. The key component for blockchain adoption, the main thing that we've interviewed many people around is, can you make sure that I feel comfortable using a blockchain in the first place? How do I manage my keys? So we're working very closely with some geniuses, frankly, in computer science and public key cryptography to introduce novel key recovery schemes. By the way, this is not the end goal. We have a couple of more very interesting key recovery schemes. But what we want to do is make sure that folks that engage in blockchain feel comfortable engaged in blockchain that, hey, oh my gosh, I forgot what I just did. What is the key phrase? Oh my gosh, I forgot to write that down. Okay, I have social recovery. I have other ways in which I can, we call it split recovery. And we have like multiple ways to do this that we're rolling out. So we think we're filling a major gap through Star Key Wallet, multi-chain. We support all the major blockchains. We'll add more support to more. In the end, it's about managing your private key in a cryptographically secure manner and also add a touch of humanity to it. Like, how do humans actually function? So more on that very soon. Moving forward, we also have our Super Scan. Super Scan's a multi-chain blockchain explorer. Well, we really try to focus on user experience. We try to make this as simple as I'm in my late 30s. My parents are getting up there as well. And I want them to use blockchains. I want them to know what they're doing. We have to make this feel as simple as Google. That's basically what we're moving towards, as simple as possible in a multi-chain environment. So our team has worked really diligently to provide a multi-chain solution that benefits, by the way, not just Supra, Bitcoin, Ethereum, Solana, and Aptos Suite, Supra, beyond all the major ecosystems, and we'll provide support for more and beyond that. But ultimately, this is the intention is a one-time shop where you can do everything you need to do. And Supra has this very clear objective to be a multi-chain infrastructure. So we do have to be able to express visually how the assets move reliably across a multi-chain environment. I'm going to rush through this because there's so much more to share here. But ultimately, Supra's moonshot consensus. John mentioned 500,000 transactions per second. This is our theoretical throughput and 125 nodes across 5 regions. Okay. Now we actually think we can do more than that with optimizations. Moreover, we only use machines they frankly use like 40% less RAM and like half as much bandwidth as some other competitors. So we feel very strongly that we could push the limits on this. And we have to ultimately design a system that can handle more and more nodes. So Supra's moonshot did get into DSN, which is a top academic venue. which is, I believe, some of the folks like Atlas Suite and some others got into. You don't just get into there strolling around. You actually are being rigorously analyzed by very serious academics in distributed compute systems, right? So Supra, through our wonderful team, through our advisors and core engineers, came up with this wonderful protocol that has been formally verified. Moreover, to estimate the consensus algorithm, and as John mentioned, already on 125 nodes globally distributed, we have throughput, theoretical maximum throughput of over 500,000 TPS, right? And I do want to mention that this does not include necessarily execution, but this is the metrics in which other competitors have benchmarked towards. So we share this as well. That said, Super has incredible information about our parallel execution strategy. This is going to be more apparent in the next 2 or 4 weeks, or maybe 6 weeks. I'll give it plus or minus. Nonetheless, our team is equally and diligently working towards very interesting, novel parallel execution strategies that should put us atop, honestly, some of the existing strategies. But more on that a bit later. Our team, also led by Dr. Kaji, Dr. Prache, and others, have innovated really incredible non-interactive DKG. So N9, non-interactive DKG distributed key generation protocols. Why is this important for blockchain? It's important because if we can lower the latency and computation required to create this DKG distributed key generation, we can do this more often. This is very important for succinct aggregation of a single signature to represent the network's itself consensus. This is also utilized for on-chain randomness. Our team is working towards very interesting collaborations with John's alma mater, which is like Berkeley and beyond, where we're doing like on-chain randomness for online poker and multi-chain environment and multiplayer environment. These are very important and difficult innovations that we're bringing forth. So I'm very proud about our team. We consist of elite cryptographers, distributed systems thinkers. And honestly, most folks, frankly, are both not only just incredible mathematics geniuses, but also they are creative geniuses. And this is how you create value. So I feel so privileged. Dr. Roz presented our Moonshot protocol recently. It's been formally verified. There's not that many protocols, public facing protocols that can actually pass formal verification. Formal verification means that we can actually mathematically guarantee that this system will not work. It will maintain safety. Moving forward here, yeah, there's, as we mentioned in our recent 125 node network tests across 5 regions, tribes and clans architecture, we have hit incredible results. Now, I don't want to spill the beans just yet, but Dr. Nimbesh, Dr. Kate, and our collaboration with the Duke University, they have another protocol that is incredible, pushing literally the speed of light type of systems. Of course, there's different flavors to protocols, but I want you all to know that Supra, as a powerhouse research entity, has the skill set to develop multiple different styles of consensus algorithms. And the results, the early results, the theoretical results are very promising. I'm so proud about our team and their development. So moving forward, you can read this about our performance and how we run these tests. And moving forward, yes, we work with some of the largest node operators in the world, onboarding more and more. Right now, we've run our Mainnet Alpha since April 14th of 2022, or excuse me, 2023, time flies back. Long story short, moving forward here, um, we are onboarding some of the best node operators, reputable node operators in the world. They're currently in our testnet. These folks will be our next mainnet alpha. And the specific date is a work in progress, but we're working towards that. And yeah, moving forward here, please read this research and then in our update, we have some really remarkable insight for the community. Supra is more than just price sheets. We're bringing something that has not existed yet. Short vertical integration, high throughput layer one, multi virtual machine support. Imagine applications from Ethereum, Solana, Cosmos, and Move language, Apple Suite. Imagine them all being able to deploy on Supra. Thus, having high throughput, low latency execution and parallel execution strategies that are novel and very high performing. And imagine applications have access to uh, Oracle price feeds, block by block, deterministic automation execution, cross-chain communication capability and on-chain randomness. We think this is going to power the next generation of super dapps. They're going to bring Web3 ultimately to the mainstream. And it has been a long journey for all of us, but we think super is going to play a very important role in this. So with that said, let me hand the mic over to our esteemed Chief Research Officer, Dr. Kate, to share more about how do we even do this in the first place.
Hi, thanks a lot for introduction, Josh. I guess my white jersey is still on the way, the one which you and Josh had. And my name is Adikit Kati. I'm the Chief Research Officer for Supra. And today I'm going to talk about the overall architecture that at Supra we have been following in this particular regard in general. To get started, first of all, it's always pleasure to hear Josh and John talk to each other. There's always something new I learn, although I communicate with them so very regularly, several times a week. There's always something new things that you hear when they talk to each other. So it's always a pleasure to hear that. Okay. Now diving into the bit more technical details, I'll be talking about our vertical integration strategies and our way to look at this whole blockchain ecosystem in general. I'm going to start with talking about the three pillars of the any blockchain. If you look at the blockchain, it's about the delivering and executing transactions. And in the blockchain space, it can be categorized into the three parts: the transaction delivery, transaction ordering, and then executing those transactions onto the blockchain environment. If you look at most of the third generation blockchains, that is the blockchain that are emerging in 2019 and so on onwards, there's always a quest for minimize latency and maximize throughput. So you want to make it as fast as you can, and we want to make sure that we can manage a significant number of transactions through our processing. And the time has proven that the blockchains who can provide indeed minimize latency and maximize throughput, indeed users like them and they see more usage, and because of them, their token valuation also keeps on improving. So this quest is just clear that we want to have fast, we have to have low latency, and we have to have as best possible as throughput. In fact, the throughput that touches very close to, and in some sense, go past a single computing environment. Towards doing that, what I've been observed in the blockchain industry is that it is not necessary that the transactions delivery should happen before transaction ordering. It could be possible that I can just order the transaction merely based on their block, based on their hashes, and delivery can take its own time. And because of that, it is possible that even when the system load increases, such ordering can help you so that ordering can continue to happen faster and delivery can follow up later and execution will follow from that. And because of that, your blockchain do not get clogged. That's certainly is a very interesting observation compared to some of the recent events that we have seen in bigger ecosystems, where as the volumes grow, there could be significant down periods. But this making sure that the delivery ordering can happen before delivery can really help in that environment. However, while this is happening, as I'm showing this example, you are just ordering different blocks, but delivery and execution can follow after that. Execution has to be in the end because it requires certainly the delivery of data, but it can be completely an offline process in general. However, what we observe at Supra and just changing the order may not be enough, because in such an environment, every node in the system is still performing each of these three actions: the delivering the transactions, ordering them, and execute them. But the question that we ask is really necessary. It becomes a pertinent and important question as the Web3 and Web DeFi environments go significantly, because the next generation of blockchain has to be comprehensive. What I mean by that is that they have to do, along with performing and delivering and executing transaction, they have to collect data from the external sources, function as the distributed oracles. They have to provide randomness service to themselves as well as to the outside world. And they may want to perform multi-party computation tasks of different kind to possibly allow a different kind of AI task in a privacy preserving manner or without that. And all these things is what's going to happen in such an environment is the same set of nodes are not only just doing transaction execution and ordering, but also doing all these and possibly more tasks. So we can clearly see that the blockchain nodes will be overwhelmed. That means as the system grow, they may slow down. And the question is that can we build our system with first principle itself so that such a overwhelming is avoided or mitigated to the best way possible? So the solution towards any such when you have to do more tasks and you're going to get overwhelmed, then our idea is possibly go two ways. Either you try to scale horizontally, that means new task, you add new nodes, or you try to scale vertically, that means you try to add more and more compute and communication capabilities to each node. And we're going to see issues with each of them. Let me start with the scaling horizontally. So let's say we have a Byzantine fault tolerant subsystem doing a particular task, and my protocol is secure and live with a 33% failure of the system. And as it turns out, now I have to do one task rather than doing just one task. I have to do two things. Let's say I have to run a consensus protocol and I have to run a particular Oracle or any other such a protocol. And the question to ask is that if I have two such subsystems which are completely independent of each other, the subsystem B is just spawned when the need arises, can we just tell that when you look at the entire subsystem, can we still make that the 30, we can tolerate up to 33% false? And answer is not actually. Assumption with which many of the current systems, even in the second generation blockchain and third generation blockchains have been made, but this is certainly is not something that can hold premise in any modeling of the adversary that we can assume. In fact, problems is certainly more general. So the key premise is the more nodes we add to the system, it increases the likelihood of the compromise. If you have a 10 node system versus if you have a 100 node system, then we can't say that the 100 node systems will be working with the exact same manner as the 10 node system in terms of the compromised nodes. The number of compromised nodes are going to increase in such an environment. And let's say I want to perform lots of tasks, as I'm showing here. Let's say I want to perform, as I'm showing here, 20 tasks, let's say. And if for each task, if I keep spawning a new subsystem to do this task, I cannot make claim that the entire system of mine is equally fault tolerant as the individual subsystem. So if individual subsystem in my example, as you can see here, is 33, can tolerate 33% failure, I really cannot claim that the entire system it can also tolerate 33% failure. That's just not something we can assume. In fact, the best way to assume is that the entire subsystem is maybe 20%, can tolerate up to 20% failures or maybe less than that. That's in fact accurate way to see. So that certainly is a slight confusion or wrong claiming we see observing into environment where even they say that each of us system is can tolerate a maximum number of failure. That doesn't mean that their entire system, their entire architecture can tolerate a much bigger equal number of failures. And that's certainly something that needs to be improved upon for sure. Now, coming back to the problem, when we scale horizontally, when we want to just keep adding newer subsystems, it certainly makes system more error failure proof. The problem with scaling vertically is that we have our limits, right? So if you want to scale vertically, there is a limit to how much compute you can add to the system. And obviously, when you talk about communication, we cannot beat the speed of light. And that means that inherently there are some bottleneck both with the computation and communication. But more so often that it also introduces a cost barrier. Bigger and bigger systems with really good compute capabilities and communication capabilities can introduce cost barrier for the validator nodes to be added. And correspondingly, then it will result into entry barrier. There will be only few nodes who may be offering something or other. But beyond that, we won't be able to allow or have a decentralization effect in place in a much better fashion if we say you have to have the machine that cost you a significant amount of chunk to begin with. What we ask at Supra is that can we do a better job with the same set of nodes as with the general blockchain environment? And obviously the answer is yes. But the one of the key insight that we made early on is that ensuring that the transaction ordering happening before the transaction delivery can offer significant advantage that is not yet fully captured by the other blockchain environment. So what we can do is that we can ensure the transaction ordering is happen for sure before the delivery. And now the delivery can take advantage of this ordering happening. And can allow us to perform improved transaction delivery and correspondingly allow us to have improved, better throughput for the value added service. Let me go in a bit more detail. So if you look at the current environment where the current blockchain solutions, they typically assume that their blockchain subsystem works, assuming that there are two-third honest majorities which are present, which we call as super honest majority. And that's a necessary bound in such an environment. However, what we observe is that if we perform the ordering separately, then the data delivery can tolerate many more failures into the system. So in fact, we do not require the super honest majority, but we only get plain honest majority. That is 51% honest majority is sufficient to do that. But the key of thing we observe, that doesn't mean that we say our system can tolerate more node and just work with that. But that means now I can work with the fewer nodes in the system than what may be required in the other environment. And that gives rise to what is known as the tribe and clan architecture that Supra has been proposing for some time. What is a tribe? Tribe is a system that requires super honest majority, that is two-third honest majority of the node. On the other hand, clan is a subsystem, it's a smaller system that each required only an honest majority among them. And what happens is that allowing this tribe and clan architecture, we can divide our system, our tribe, into multiple clans so that we can do a better division of the task. So let me take an example. Let's say I want to perform a full task into the system, and each of them require their own distributed compute and communication environment. In a tribe architecture, each of my node will be doing 5 tasks and they'll be overwhelmed. On the other hand, if I can make sure that all of those 4 tasks can be performed into clan architecture while requiring only ordering happening into the tribe architecture, then each of the node will be only performing 2 tasks. It will participate in the transaction ordering process, which has to be done in a tribe level, and one more task. So you can see the nodes load in such an environment gets significantly reduced because of this such an example. And as the systems become bigger and bigger, as we have more number of nodes in a tribe, the number of clans also keep on increasing, as we have seen with our statistical analysis. So that certainly allows Supra to scale much better than many of the environment that are emerging or have emerged, while maintaining a really good level of security. So the another insight in general is that these clans, where the problem that we can solve just with the honest majority, are very common in the blockchain environment for different tasks. Assuming we have access to an arbiter chain, which basically just an ordering chain where transaction ever take. And as I mentioned, this is assuming that we're working in asynchronous or partial synchronous environment, which is certainly an important plus point here. So, with that, now I'm going to provide a high level overview of how Supra look at the things. Over the series of webinars, you will be looking at each of these aspects and more aspects into more details from the different researchers in our team. But what my aim here is to provide a flat overview so that you can take that home. And when you come to our next webinar, you are much prepared to ask very interesting questions to us. What we want when we look at our Supra approach is we expect that we have an arbitral chain that executed over the entire Supra tribe. To run this chain, we'll be using our state-of-the-art moonshot consensus protocol. The key thing to observe here is that no data or transaction flow through this process. We only deal with the hashes and small summaries of the data. And that's the reason moonshot remains extremely lightweight, where its performance actually is much better than any of the other solution in the blockchain solutions or state machine replication solution in the space today. And once we do that, then our aim is to solve all other problems at Supra or in general in the clan environment. And that include reliable data delivery. This can be available applicable to data availability of all different kinds, or as well as transaction, making sure the transaction delivers and execute in such environment. Obviously, transaction execution, so that we can generate the states that can be available to the RPC nodes and to the clients, can be solved in a single clan environment. And this do allow us to have a really good sharded execution system where we can significantly improve the performance in general. We can perform threshold cryptography, multi-party computation. We can provide randomness services or services of different kinds through such environment, possibly also including the services for the AI, and as well as the being a really good oracle that can be available with the system. It's important to observe that we are not making any synchrony assumption, which can be very dangerous when we want a high throughput and low latency system. So there is no broadcast assumption here. And all our solutions are purely asynchronous so that they can work even when network become extremely unreliable for very rare event, like solar flare event kind of can still be tolerated in such an environment where we maintain the complete safety. So the money and the safety is always maintained even when the extreme events are happening that we cannot control or humanly possible even in our environment. So with that, yeah, I'm coming to the end of my talk. Thanks a lot for listening to me. I'm always available on Twitter or in any mechanism to answer all your questions. And I really enjoy communicating with the people, and I look forward to engage with your questions now with Josh.
Absolutely. Yeah, Dr. Kate, thank you for being so clear about our innovations. What I want to do is ask you a couple of questions about some of our insights that are not so obvious to the average person. For example, the first question that comes to mind is, what is the status quo? What's happening right now for verifiable compute, which includes Oracle, VRF, and what's happening right now? Most folks, I think, execute this across 2+1 of their entire system. How does Supra differ in this regard?
Yeah. One thing that we observe at Supra is the verifiable compute problem is actually not so different from our Oracle problems at the conceptual level. And what we started to observe in such an environment is that now, once we look that problem in such core way, the modular way, as we always talk about, then we can indeed solve this problem in a very conceptual fashion and providing solution where many versions of this verifiable compute can also become a clan problem. In most other environments, what's going to happen is that they will have to solve this problem with two-third majority. So to provide the same safety level as Supra can offer, they may have to work with a significantly more number of nodes. But at Supra, we could manage that to solve this problem with having high level of security while maintaining a low latency and conserving our resources so that we can provide many solutions in a modular fashion.
That's right. That's right. So you use the word modular, and some folks think about, okay, modular architectures. Okay, one system for execution, for data availability, another one for Oracle, another one for cross communication. These are disparate networks, right? And if you ever send a request to a disparate network, remember the speed of light is approximately 133 milliseconds. You send it in your request, and those nodes should be distributed. And then they have to calculate and execute it, and they have to communicate with each other, and they're sending you a response. And many times this is a synchronous approach, meaning one thing has to happen with the other. And as you described, what's really interesting about Supra is that we can focus on ordering first and then execution after the fact. And as you mentioned, in summary, what's happening is the following. The current status quo is that 2/3+1 of all the nodes in any system has to be reaching a super majority agreement. But at Supra, what we can do is we do a random shuffle of the node composition to subsets called clans. Those clans with high probability, with having this security guarantee, can exist with 51% agreement. Why is that significant? It's significant because most systems say, hey, look, we need 67% of all nodes in the system to come to an agreement. But we have realized that we can actually come to a 51% agreement in a subsampled set, randomized subsample set. So ultimately, I guess this kind of leads to the next question, which is, this may lead to better performance while maintaining decentralized security and speed. And Dr. Karthik, if you can just chime in about why randomization matters and like why is it that we can actually do this in a subsample set so that traditionally most systems need 2/3+1 or 67% of all nodes in the system to perform this. But why does it work in a randomly subset clan where only 51% of nodes are able to come to agreement? And why does that result in better performance?
Sure. I want to add here that, so let's say we don't do any randomization, okay, to begin with. Think of it, that's actually case with some of the designs in here. I want to indeed come to the word modular itself, because I think it has become, it's, for me, it was never, but I think it has become a confusing word in the ecosystem. But yeah, coming to the thing, right? Let's say the system is not randomized. Now you take your nodes and you assign them to different different tasks, but over the period, it can happen that your structure is known to the parties who want to take down your system. They can slowly start crawling to system and start capturing some of your validators and node. And eventually they may be able to take over a particular subsystem. As we mentioned in the introduction, there can indeed a weakest link in the system, and your weakest link can take down at least a part of your subsystem in such an environment. What randomization helps is that if you keep on randomizing your architecture at every epoch in your system, then adversary will have a moving target to go after. And as it is a moving target defense in some sense, that, oh, if you want to, let's say, take down the Oracle approach, you can't do that, because the moment you start doing and you are halfway through the system, now different set of nodes are going to provide the Oracle service after randomization after epoch. So randomization indeed offers in that what we can call as moving target defense or adaptive security, which cannot be offered in the systems which are completely stationary. And with that, then I have to come into the point a concept of what happens into other environment. Let's say you have a new task, you find out different set of nodes and make them do that particular task. As I was showing in my on my slide, we cannot give guarantee that my entire system may have the security at the same level, because now adversary can indeed go after those nodes in that subsystem and take that subsystem down unless you do randomization. And moment they start to talk about doing randomization in such architecture, which really don't want to call modular. Because if I want to do a new task and if I just find new node and make them do that new task, we'll not call that module. We just call them as a separate process, right? They're not part of the entire system or cohesive system. It's just like I need to do new task. I just find out new node and make it do it and believe that the entire system is just functioning correctly, or have shared security is not a correct argument to make for sure. And then coming back to discussion. So with that in premise, what Supra observe is that you really don't need to spawn the new node. You can use I have an entire system. In my entire system, I have truth and honest majority. When I pick subsystems of them, I can make sure that for each of those subsystems with a statistic beyond only due to only up to a small statistical layer, we can always make sure that they have the security or shared security of the entire process. And even beyond that, we'll keep on randomizing them every so often so that we maintain a security at much large level. And recoveries can happen in the meanwhile for the nodes that go down. So this can offer indeed a long-term adaptive security for our architectures.
This is a key word you said, adaptive adversary, adaptive security. Right now, what's happening is you have a static set of nodes that are doing a particular service, and those nodes may not actually rotate or change. And therefore, if you're a Byzantine adversary, you could target those nodes. But imagine there's a target rate and correction rate of, let's say, one node for 3 hours. And Super has an heap where we randomly shuffle that constituents every 24 to 36-hour period. It mitigates the ability for you to have this hyper aggressive adaptive adversary. Most systems do not consider that, which is a very key insight. And also about this, what's interesting about this is that, so some folks ask, okay, if you're randomizing the nodes, how do you do a state synchronization? What's really interesting that our team has observed is for certain systems such as DORA, Protocol Decentralized Oracle Agreement, or Oracle Spreadsheet, as well as our on-chain verifiable random function distributed BRF, these are not stateful. So you don't necessarily have to do state synchronization for those nodes because these are new data coming in and new computations. Of course, if we were to randomize our nodes that are doing the execution sharding across virtual machines, there is a synchronization process. Now, that is a little bit beyond our scope, but Supra we have actually like more than one technique to get there. And they're both very good. At least two or three of them are very good. And we're going to be rolling out our strategy in the next weeks and months to share how we do that. But yes, state synchronization is only necessary for certain types of tasks like consensus and state execution. But Oracle, BRF, and some other tasks don't necessarily have to do that, which is very interesting. In the end, you already touched upon this, Dr. Kate. What are the limitations? Like traditionally speaking, okay, we have nodes that are doing consensus. Okay. You have eigenlayer that have also had a similar realization. Eigen is saying that, hey, the same nodes had more bandwidth and compute to do other things. But Dr. Hatch, from your point of view, ultimately, when thinking about consensus nodes running multiple services, what are the limitations on the node itself? What's your point of view there?
Yeah. So for sure, as the number of transactions that we need to manage in any subsystem continue to grow, there is always trade-off between latency and throughput that has to be looked into. And eventually we are stuck with the Moore's law and the speed of light to this environment. But the key thing is to come as close as possible to all those limits is the goal for us for sure, and for several other things. So, if we can call ourselves the third or fourth generation of blockchain, we can certainly say that we want to actually try to come to as close as possible to the natural limit of computing and communication, and show that we could. The ultimate goal is to somehow demonstrate that even if we will have a single computer, like how the Visa works today, distributed computing can actually do better job than that by providing the similar level of security. That can be looked at as a goal in general. And the thing is, indeed, that's where whole this vertical integration and different node performing different tasks and the sharding approaches can be really helpful to overcome, to have a distributed system which has distributed system security, but still performance which is at par with the single subsystems or single system security as our current Web2 environment like Visa and others are using.
That's incredible to state. Imagine that, folks. And I completely agree with Dr. Kate that a decentralized technology is going to outperform centralized technologies. And this is not what we ever would have thought be possible. We're here today, though, is claiming that with a similar security guarantee, decentralized technologies can outperform on the order of 10x of centralized technologies like Visa, MasterCard. Moreover, the key points that Dr. Kate pointed out, really, it comes down to first principle thinking. Speed of light, but that is a limitation that every protocol, all of us have to deal with, right? And then we also have computational limits that we all have to deal with. Now, just tied together, Supra's major insight with vertical integration is that, okay, certain services don't necessarily require state synchronization, and certain services do, but we have this delineation and randomization approach where ultimately we are ultimately really the whole game is to push against the limits of the speed of light, period. And all of us are looking at the same problem set. We have different, unique approaches to it. And Supra, with Dr. Kata's insight and elaborations, and with our team, we are pushing the limits to bring forth the vertically integrated layer one next generation infrastructure. Dr. Kata actually said third generation, even fourth generation. I would also argue that we're on the fourth generation tier of blockchain technologies. And Satoshi Nakamoto with Bitcoin never necessarily would have thought that this technology would have outscaled Visa. But I'm here and with our team saying we may 10x it in throughput and capacity and latency. Well, latency is another conversation, but we're very close to the speed of light. And this is something we always push forward towards. There's more to discuss here, but ultimately a blockchain that only has ordering and smart contracts is not enough. We think and we know through the fact that Super has deployed to 78 ecosystems, layer one is layer twos, even Bitcoin layer twos, is product market fit for both cross-chain communication, price feeds, automation, on-chain randomness. These are fundamental primitives that every ecosystem needs so that smart contracts can be more expressive. And Supra is vertically integrating this all into a what do you call it? Multi virtual machine environment, right? And this is what we claim to be the actual iPhone moment for blockchain technologies. In the next several weeks here, Supra's team collectively, we're going to be revealing many more insights in our technologies. This is a wonderful high level overview as why we think that vertical integration is important, that this will create emergent value for applications, create super dapps. And Dr. Hudson, thank you so much for explaining very clearly how our Triton Clan's architecture works and how we can maintain security, decentralization, and resiliency while being a multi-service platform. So with that said, we're over time and we'd love to invite some folks that have some questions. But we can only do maybe 2 to 3 minutes of questions if you have some questions here this time.
Okay, great. So hopefully you can see that Supra is a research first organization. We lead with research. And once we prove the research and we know that we've built out a system that is vertically integrated and the most efficient as possible, then we ship. It's been a 3-year journey. To be honest, we're going pretty fast. So I'm excited. We do have a few questions. I know there was a question about the time card. I know we talked a lot about scaling from the distributed system level, but also I guess sometimes it's interesting to think about from the hardware level. Josh, is there anything we can add here about the time card? Is that something we want to add later?
Yeah, Supra is both algorithmic driven and also ultimately our focus is on the highly performant system pushing against speed of light. That's the limit for all of us. Now, the time card technology is something that we're very interested in. Now, it turns out that maybe our moonshot consensus protocol can actually outperform because it just adjusts based off of network parameters. Nonetheless, what's really interesting about the time card technology, which we are also continuing to explore, is that we can imagine if we had this notion on the nanosecond of the network's condition. So, for example, we right now the network's congested, so we can adjust the delta, the timeout differential of okay, new rotation. And before we say, hey, we're timing out, we're going to elect a new leader or certain types of performance. The time card using similar protocols like our DORA, decentralized Oracle protocol, to have a notion of time in our system. These are things that we're exploring. We actually think there's something here. We're working closely with time card manufacturers. And let's just put it this way. There will be more versions and iterations of our protocol. Super will never stop iterating performance. And that's our superpower. Our superpower is that we will always be devoted towards what is the best performance system while maintaining security and decentralization. So time card is in the cards. It may not be at day one. It may be in a version 2 or 3, but it's something that we're proactively exploring.
Great. So I have another question about formal verification. We talked about how moonshot consensus is formally verified. And there are not many consensus algorithms out there that have been formally verified. And so that's a huge achievement by our team, by our research team. And a question was, do we have a formal verification process for smart contracts or other key components at Supra?
Maybe I can ask Dr. Kachi to
Yeah,
chime in.
indeed. Yeah, that's a very good question. And good to have audience who dive into these things so much detail. So I want to answer that question in actually 3 parts. So the first thing is indeed the formal verification process that is laid by Dr. Ran, where he did it like he is really passionate about that. He worked at the project on that. We demonstrate that our protocol is secure and remains safe against any kind of a boundary conditions and cases like that. It has happened for many of the really good protocols in this space that there are always some boundary condition where they wouldn't have functioned correctly or may be misconfigured to a small level. But the forward verification makes sure that you take all those doubt out of the picture and you know that what you have is correct protocol without any flaw, which is either into the protocol, which maybe we miss in our other analysis. So that's what the consensus algorithm. Now, when we talk about the smart contract verification, one of the key things that we already decided that we wanted to have an environment indeed where uh, we provide services where we know that when user writes smart contracts that they are indeed secure by definition and the users unless the errors are in the patterns the errors are not happening because the compiler or the underlying smart contract environment. And that's the reason working, discussing, and working quite a lot. But on our own side, we found that the move is certainly the right direction to go for the Supra's native smart contract environment. That's the reason we went for this environment. Move is made in a fashion so that indeed, when you write a smart contract, that at least there are no re-entry bugs or other bugs which were inherent to the Solidity environment. And that's certainly that was a cautious choice that we have made to make sure that we want to have the state of the art, the most secure environment to offer to our Dapp developers who want to build Dapp in the Supra native environment. But at the same time, we know that the Solidity is certainly the most prominently employed mechanism into such an ecosystem. And given that the idea is that we are always following the industry standard for all the verifications and auditing for the smart contract, the Supra is putting onto the same environment. When Supra is offering service to Ethereum environment, we have to work with those smart contracts written in Solidity, or similarly for other ecosystems. And our aim there is to follow the due diligence to the level so that we are confident that our smart contracts will always provide reliable service without any glitch and the safety issues.
Absolutely. So just to summarize, Supra's backbone governance and system itself is going to be move language based. Developed at Facebook and the folks at Aptos Sui and Aptos. Sam at Sui is the CTO of Sui, the founder of Move Language, and we have adopted the core Move language to be our backbone. And bottom line is Supra will support multi VM support. And at the same time, at the consensus level, the form of verification, the move language level, there is inbuilt security guarantees. And at the same time, we do promote best practices, of course. Wonderful question. Thank you so much. Let's move to the next question.
Sure. So I have two more questions so far. Let's see if any others pop up. But here's a question for us. So we went from Supra oracles to Supra. What happened? Why aren't we focused on oracles anymore? That's the question.
Okay. I can answer this. So believe it or not, November like 17, 2027, 2020, 2017, excuse me, back in the day, it was very clear that adding oracles enshrined into a blockchain made so much sense to enable smart contracts to do more. I was actually a Link Marine back in the day. I was like, wow, it makes so much sense to bring Oracle data to a blockchain. What I was not super happy about over time is that they become disparate systems. It seemed clear that you should vertically integrate it. Now, if you think about our path towards go to market, we actually have always had a consensus algorithm planned, which we've upgraded to Rootshot. And we also had that be our backbone with our Oracle protocol. Now, we made super huge improvements across the board on all these. Some of our assumptions were not tight enough or correct enough. We refined them and we made our system much better. And ultimately, this notion of vertical integration actually is seeded back in 2017 and expanded upon only with the help of folks like Dr. Kartik, Dr. Rag, Dr. Yang, Dr. Parwat, Dr. Joshi, and Biano. We have such a wonderful team. And in the end, the question was the following: hey, can the same set of nodes do more than just consensus and Oracle? Remember, this was 6 years ago. And to this day, we actually decided to design a system in which we can do what's called sharded execution. Randomized nodes are randomly designed, designated to subsets. Those nodes and those subsets called clans are doing different services. But those nodes and those different clans should be doing more than one service. It all comes down to first principles thinking. How much bandwidth, how much compute is available. And that's what we want to exploit. That is how you have generative value. So the answer is it was not always focused on Oracle. Maybe John can talk a little bit about the strategy behind that. Like we always knew we were going to do more than just Oracle. So you could talk
Yeah.
about that.
Yeah. If you can imagine, bootstrapping an L1 is not easy. Most successful L1s either came out of Facebook or they come out of some getting hundreds of millions of dollars of investment and gaining that amount of treasury to be able to market and to be able to attract applications to develop onto their chain. And we started in 2008, 18, as we mentioned before, in the last bear market. This is the bear market before the last. And we were honest with ourselves at that point. If we can't get funding, what is a way that we could bootstrap an L1? And then DeFi summer comes along. We saw all these Oracle exploits. We're like, you know what? We're going to bootstrap an L1 by going to market with a product of Oracle first. So we're going to call ourselves Supra Oracles, and we're going to interconnect with every chain out there. And so today we're interconnected in terms of Oracle pricing data to 77 chains. So it's not like we've stopped focusing on Oracle. Actually, we believe we're the best Oracle out there because we're applying L1 security principles to solve the Oracle problem. So the goal here was to create a product as Oracle that helps us go cross-chain, interconnect with as many chains as possible to think and to push our vision of having a fully vertically integrated L1 with native Oracle and bridging to enable the best, for example, the best layer one itself, but also to enable better cross-chain communication. And so for us as an Oracle and our strategy from the business development side is giving the world a public good. L1 itself is a public good, but the Oracle as a public good, offering it for free, in many cases, allows us to create connections with all these different ecosystems and all these dapps that need our services and they can't get it from others. And so it was a business development strategy. And I have to say, of course, in hindsight, it worked, right? So it really did. It worked. So we went to market as an Oracle, giving this public service, public good. And now we can flip on a switch and we can now say, hey, we've been building from the beginning a vertically integrated L1 with these native services. You can deploy directly onto Supra and be cross-chain enabled. And that's exciting. And it turned out to be a wonderful strategy.
So to share a little bit more on that, a little bit of alpha for the folks here. So Super is deploying a competition. So we have deployed to 77, 78 ecosystems across our Oracle price feeds and on-chain verifiable random function, maintenance, testnets, etc. Now, what we're doing next is we're inviting these folks that are using our services. Hey, by the way, why don't you deploy directly on Supra for multi-virtual machine support? You can deploy on Supra and take advantage of our data price feeds. Imagine block by block, you have price feed data. You have access to our on-chain verifiable random function, block by block. You have cross communication capability and also automation capability. Your application and your ideas can become super dapps, something you literally cannot build elsewhere in a single environment. And this is now we went broad, now we're bringing them back in. And this is what we're doing and executing on a day by day fashion. This is this year's plan. We need your help and community's support to invite folks. By the way, our performance is off the charts. It really is. And we have what we truly believe is the best Oracle protocol and got accepted to ICTCS, top academic venue. Remember, Super does not share and gloat about what we can do without getting data first or peer shoot double blind peer review. And we haven't gotten accepted to top academic venues multiple times. We take research first. We are not degen first. We are research first. We'll always do research and fundamentals first. And has that handicapped us in the back in the past? Maybe a little bit. But guess what? In the long run, what matters is being right, improving it. Performance in the end, formally verified consensus algorithm, that's going to attract institution. You cannot run a business on a chain that constantly, could we call it, has license issues. Visa, MasterCard maybe are there today, but they're going to eventually go to ecosystems which have better performance. We focus on high performance, formal verification, and a better developer experience. So with that said, I think that's the last question. Is there any other questions, Sean, Dr. Patti, that we want to address? Okay. We have another week of these, another 5 weeks of these, maybe up to 6 weeks of these coming up. Please tune in constantly. Yeah, May 1st. Dr. Patti, thank you so much for being so eloquent in explaining the difference of what we're doing and why it matters in summary, what's really cool about Supra, and this is a key insight that Dr. Kate really zoned in on early, is that we can have randomly sampled subset of the network running these protocols at 51%. No more protocols need 67% of all the nodes in the entire network to do the work. But if we have the subset doing it, we can be a multi-service architecture with shared security, low latency, and high performance. And so grateful to be here. Thank you, Dr. Kotick, for your time. John, thank you so much. We'll see you guys in a week. Thank you all.